Hey everyone, welcome back and thank you so much for joining me today. This is another physics crash course, but today we're talking about momentum. If I initially start off by pushing this cart, all the momentum, and this has no momentum. So once this cart makes contact with this one, it transfers all of its momentum to this cart, as you will see right here. See, it stopped and it transferred it all to the other cart because these two carts have the same mass. When they transfer their momentum, they each have the same velocity. Super profound how you can just look at this system and realize that momentum is conserved because this cart transfers all of its momentum to this one, and then once it bounces back, it collides with this cart and transfers the momentum back. None of it is lost, it's all just switched between these two carts. So now that you guys saw the phenomena occur where the first cart pushed the second cart, and once it pushed the second cart, the total velocity of the first cart completely stopped, we need to understand that mathematically. How is it that you get that and why? The math just explains it to a better degree. So before we get onto that, let's define what momentum really represents. Momentum has been written as P throughout history. P for momentum is equal to the mass times velocity. V for velocity. Essentially, momentum is anything with mass that is moving at a certain velocity. So don't forget that concept. So now that we have that covered, let's draw our two scenarios for this system. Initially, so I'm going to put I for initial. The initial system was consistent of two carts. And these two carts had the same mass, M. Let's just call it M. But only one of those carts had a momentum. This second cart was stationary. Its velocity was equal to 0. And by understanding that, we can have our initial system in place here. Our final system, as we saw from the experiment, ended up giving us the first cart ended up stopping. Its velocity was equal to 0. And the second cart continued moving. Like the momentum transferred from the first cart to the second cart. So let's draw that for the final system. You have the first cart. After it collided with the second, it completely stopped. So the velocity for the first cart turned out to be equal to 0. Now, the second cart ended up obtaining a velocity, which we're going to call V final, because the final velocity was then obtained from the interaction of the first to the second cart. What was that velocity though? We're going to leave it as a question mark. If we assume the initial system had a velocity of 5 meters per second, we have everything ready to figure out what the final velocity was. Essentially, the momentum just transferred over to the second, and the second cart continued moving at that same pace that the first cart initially had. So mathematically, how can we prove that? So now we have our initial and our final system. Conservation of momentum says that the total momentum in the first scenario has to equal the final momentum in the second scenario. So let's draw out the system. Momentum initial has to equal momentum final. If we have this equation, let's write out all the individual momentums initially and all the momentums in the final state. So going on this side, initially you only have momentum in one cart because this one is stationary. So in the initial scenario, you have the mass times the velocity, which is 5 meters per second. Okay, for the final system, because the first cart has no velocity, its momentum is equal to 0. The second cart now has a momentum because it has a velocity. So let's write that out. You have the mass, and now we're gonna write V final because we don't know what that actual velocity is, but we do understand that we can figure this out with this equation. So now if we plug in this, and this momentum final to this equation, we can try to figure this out. And if we end up replacing the initial scenario's momentum and the final scenario's momentum into this equation, let's see what we obtain. So let's write it over here. This initial momentum is the mass times the 5 meters per second. So as we see, that's initial momentum. That's equal to the final momentum. So let's make equal sign and let's write the final momentum down. Mass times this unknown, which is what we're trying to prove, the velocity of the final cart. Now we have it all written down right here. What you can see is because the two carts have the same mass, the masses cancel out, because if you divide the mass to both sides, they cancel out. And what you end up getting, if we erase this and write it over here, is the simplified equation that 5 meters per second is equal to the final velocity. So this ends up proving that the final velocity is the same as the initial velocity from the first cart. So the total momentum was indeed transferred over to the second cart. And it was apparent because the first cart completely stopped while the second cart took off. And when they came back and collided again, it transferred all of its energy. So mathematically, you can prove this. And that is why the concept of conservation of momentum is so vital. Thank you guys so much for staying until the end and watching this video. I really hope you guys understand now why I love momentum so much. It just explains how the universe works. Just even in everyday concepts like carts, it helps us understand why it is that motion transfers over to other objects, and I hope I instilled a little bit, any kind of enthusiasm or curiosity about momentum. Thank you guys so much for watching. I'll see you guys next time.